So the higher potential one gains electrons, the lower potential one, it loses electrons, right? And your data booklet, where's the data booklet? Just a second. So now here's the, where did it go? So here's the data booklet. It's got all these electrode potentials, which are measured relative to the hydrogen electrode. All electrode potentials are measured relative to something. So remember, the value, whether it's positive or negative, that is meaningless unless you compare it with something. So if this is 0.34, it might be a higher potential if you compare it with 0.15 moles, or it would be a lower potential if you compare it with 1.33 volts. So always remember, it's a relative comparison. Which one is a higher and which one is a lower potential? So the last thing that we did in the last class was that if you're given two random electrodes, you don't have to do anything. You can figure out the reaction by just looking at who has the higher potential, who has the lower potential. Lower one loses electrons and the higher one gains electrons. And we can do a similar question. I can pick any two electrodes from here. So I can pick any random electrode. So for example, I can pick the CR3 plus and CR electrode and use that as one of my electrode. I don't need to draw the diagram every time. So I'll just use this equation, just make it smaller. 1 second. So that's one electrode, and I'll pick some other random electrode. For example, I can pick the Fe3 plus, Fe2 plus electrode, which is this one. So I can connect it with this electrode. And if I do that, just 1 second. So I'll just connect it with this electrode. Now again, always remember, it's a relative comparison. So this one is a higher potential, which means the higher the high E naught wants to gain electrons. So it's going to go in the forward direction. If it's connected with the electrode on top, which is minus 0.74 volts, and that's your lower E naught. So that is the one that's going to lose electrons, and you'll be able to figure out what the redox reaction is going to be between the two. The only thing you have to do is you have to balance the number of electrons that are gained and lost. So for example, this needs to be multiplied by 3. Why? Because, and this is only for balancing, because there are 3 electrons being gained. So on the other side, there must be 3 electrons that would be lost as well. So the electrons need to be balanced. And the next part is you just add up the reactants and you add up the products. So the reactants in this case are, in the first one, the reactant is CR, and in the second one, the reactant are these two. So you add up the reactant, it's going to be CR plus it's going to be Fe3 plus. The electrons are going to get cancelled out anyway, so I'm not going to write down the electrons. The amount of electrons gained and lost are equal. And the products that you're going to have in the first one, the product is CR3 plus. And in the second one, the product is 3Fe2 plus. And we've been able to figure out what the reaction theoretically is supposed to be. It's going to be chromium reacting with Fe3 plus, and it would produce CR3 plus and Fe2 plus. By looking at the electrode potentials, we were able to figure out who was going to get oxidized and who was going to get reduced. And we can also figure out the E naught cell, which is the potential difference. Last time we had a discussion on E naught cell. E naught cell is reduction E naught minus the oxidation E naught, or which is basically how you calculate potential difference. It's going to be higher potential minus lower potential. So it's going to be 0. Which one is the higher one? It's 0.77. And you're going to subtract it with minus the lower one, which is minus 0.77. 7.4. So I think that's going to be, I think it's going to be 1.51, probably 1.51 volts. So the potential difference of an electrochemical cell would give you an idea of how quickly the electrons are going to flow. How quickly would one side gain electrons and the other side would lose electrons. So that would give you an idea of how fast the reaction is. A greater E0 cell, high E0 cell indicates the electron flow will happen more quickly, and it's going to be a more feasible and faster reaction. So this one has a pretty high E0 cell, which means it's going to be a very vigorous. It's going to be a very vigorous reaction. So is this example clear to everyone? Is this clear, Sam? Is this clear? Zoha?
Yes, sir.
Clear, sir.
Now, so now the next, so just remember that's just the basics. It's higher potential gaining electrons, lower potential losing electrons. Now the thing is, when you're trying to figure out whether a redox reaction would happen or whether it wouldn't happen, things would not be this easy. They won't tell you which electrode is. I mean, they wouldn't just give you these two electrodes. Most of your questions are going to be like this. You wouldn't know which electrode to select. For example, so this is how you're going to predict a redox equation. And I'm going to write down the steps as well. So they'll just give you two random substances. They won't tell you which electrodes it is, because then things are easy. Like if you know what the electrodes are, it's kind of easy. The higher one gains electrons and the lower one it loses electrons. So things are not going to be this easy when predicting redox reactions. So here's going to be an example predicting redox. And I'll write down the steps as well. Now, first thing when it comes to predicting redox reactions, let's take an example first. I've got copper, and copper reacts with FeCl3, and FeCl3 is aqueous. So copper over here is a solid. So I want to figure out what is the reaction going to be. So at the moment, I have no idea. I don't even have any idea which electrodes to pick. So step number one is you have to figure out what your reactants are. Okay, that's step number one. Who's your reactants? And when you list down reactants, what you have to do is you got to treat ionic compounds as separate ions. For example, if there's NaCl, in the data booklet or in the equations, you wouldn't see NaCl together. You'll see Na+1, you'll see Cl-1. There'll be separate reactions for them. So ionic compounds should be treated as separate ions, or ionic compound ions should be dealt with separately. So for example, in this case, it's FeCl3 aqueous, but I mean, you won't find an equation where FeCl3 is gaining electrons. It's either Fe3 plus or it's Cl-1. It has two separate ions. So ions should be dealt with separately. So I'm now going to list my reactants. My reactants are copper. That's one of my reactants. And I've got the other one is Fe3 plus, and I've got Cl-1. Now it's one of these three reactants, is going to gain electrons and the other one is going to lose electrons. At the moment, I don't know which ones. So let's move to point number two. The second thing that you're going to do is, now Now, and we don't even know which electrode to use. Like I don't at the moment have any clue what's going to happen to copper. Okay, so the previous scenario is easy when the electrode is given. But at the moment I don't have any idea what's going to happen to copper. For example, there are many electrodes given for copper. If you look at copper metal, it's in equilibrium with copper +1, so it could turn into copper +1. If you look at this electrode, copper can turn into copper +2 as well. So at the moment, I have no idea what is going to happen to copper. So I'm going to write all these reactions. So point number 2 is you're going to write all electrode reactions. So write all electrode reactions involving the reactants. All possibilities. Because at the moment, we have no idea what's going to happen. So all possibilities. So I'm going to pick. I'm just going to copy paste instead. So I'm going to pick these two electrodes. So I've got copper over here. So let's so any place where you see copper. So both of these reactions involve copper. So I'm going to pick both of them. So let's just pick both of them. So here are both of the both of the copper equations. Is there any other copper equation? There's another one, which is this one. So there was this one. I'll just put a tick mark just a second. So there was this one, and then you had this copper equation, and then you had another copper equation, which is this one. So there are actually 3 equations, but I'm not going to pick this one because the rule is that something should happen to your reactants, which are copper, Fe3 plus and Cl-1. But if you look over here, copper is reacting with NH3. I don't have NH3 in my reactants, so I'm not going to use this equation because copper in this equation or in this particular reaction reacts with NH3, which I don't have. So let's stick to this. It should involve only a reactants, not some other reactant. Which so NH3 is out of the question. So I'm not going to pick that equation. Is this part clear up till this point? Sam, is this clear? Nadine? Zaheb? Clear? Alicia, is this
Yes,
clear?
sir.
Achha. So we're done with the first one. I've written down all possible reactions for copper. And then let's move to Fe3 plus now. So what's going to happen to Fe3 plus? I don't have any idea. So I'm going to open the data booklet. And I'm going to pick all reactions involving Fe3 plus. So there's Fe3 plus over here. It can gain 3 electrons to form Fe, and it can gain 1 electron to form Fe2 plus. So no idea what's going to happen. I'm going to pick both of them, and we'll figure out later which one is the right one. So so both equations copied, and so here are both of them. And let's see if there's any other Fe3 plus equations, which I don't think there's any other place where Fe3 plus is coming in. Only these two. And then we have Cl-1. So for Cl-1, the equation is this one. There's another one which involves, there are two actually. There's this one, and there's this one as well. But I'm not going to copy the second one because Cl-1 reacts with OH-1. I don't have OH-1 as my reactant. So since there is no OH ions, I mean, there's no point writing this equation because that's not going to be a possibility. You need OH ions as in your reactant. So I'm going to pick the first one. And let me just rub this off. So 1.36. So this one. And we'll copy this. So I've written down all my possible reactions or all my possible electrodes that can possibly be involved in this reaction. Remember, the focus is on my reactants. Something is going to happen to my reactants. Someone is going to gain electrons and someone is going to lose electrons. And I've written down all possible electrode reactions. Although you don't have to actually copy them again because the table would be given for you. So you can just mark the equations in the table. Okay? So that will save you time because the table would always be there for you. Now, the next part is, let's move to part number 3. So I've written down all possible reactions. Point number 3 is, so who's going to gain electrons? The highest potential, high E naught gains electrons and the lower E naught. So gains electrons and the lower E naught loses electrons. That's it, simple. What we have learned earlier as well. So high E naught gains and lower E naught loses. But you have to ensure that, make sure that it's your reactors. I mean, I just wrote these random equations. Anywhere I saw copper, I wrote that equation. Anywhere I saw Fe3 plus, I wrote that equation, and Cl minus 1. But we have to make sure that it's our reactants that are losing or gaining electrons. So if I pick an equation, it should be my reactant, which I stated earlier. They must be the one that would be gaining or losing electrons. Otherwise, that it wouldn't count. It should be someone out of these 3. So out of all these possible reactions, which one has the highest potential? The highest potential belongs to, I mean, this one comes out to be the higher E naught. Now focus on this carefully. This one is the highest E naught, which means this has the highest tendency to actually gain electrons. 1.36 is the highest. So that means this reaction is going to go in the forward direction, and it's going to gain electrons. But I'm not going to pick this equation. Why? Because if I were to pick this equation, then who's gaining electrons? It's Cl2 that's gaining. It's Cl2 that's gaining electrons. And my problem is that if I look at my reactants, I don't have Cl2. Like over here, if I look at my reactants, I have Cl minus 1, but I don't have Cl2. So it must be one of these 3 that should be gaining electrons, which is why I'm not going to use this equation. Although it is the higher E naught, although it has the greatest tendency to actually gain electrons, but I can't pick this equation because I don't have chlorine in my reactants. So if I don't have chlorine in my reactants, I'm just going to ignore this equation. And I'm going to look for another high E naught. So let's just ignore this equation. This one is not the one. Let's look for another high E naught. So if I ignore that, the high E naught now is this one, 0.77 volts, which means iron 3 plus ions are the ones that are going to gain electrons. They have the highest tendency to actually gain electrons out of the remaining 4. So who's going to gain electrons? It's going to be Fe3 plus. Do I have Fe3 plus? I do have Fe3 plus. So that means this equation is fine, because this equation states that Fe3 plus is the one that's going to gain electrons. So there's nothing wrong with this. So I'm going to pick this equation. It's a perfectly fine equation, and Fe3 plus is going to gain electrons. Is this clear up till this point?
Sir, can you please explain this Cl2? Why is it not a part?
Listen, out of all the 5, okay, who has the highest potential to gain electrons? It's 1.36, right? Which means Cl2 has the highest potential to gain electrons. So if there were 5 electrodes and I wanted to select which one wanted to gain electrons, it was going to be Cl2, right? But the thing is, it doesn't make sense in this case. Why? Because, I mean, look at my reactants. I don't have Cl2 anywhere. So if my reactants were, remember, I was predicting a reaction of copper with FeCl3. So there is no Cl2 anywhere. So how can I select this equation? Like, where did Cl2 come from? There is no Cl2 in my reactants. Do you get my point?
Yes, sir.
Okay. So the last point jo tha na, usme there was this important point that you're going to select the high E naught which gains electrons, and you're going to select the low E naught which is supposed to lose electrons. But you have to make sure that it's our reactants that are going to gain or lose electrons. So Cl2 is nowhere. Okay, we don't have Cl2. So which is why I'm not going to use Cl2. Okay, so this equation is out of the question. So remaining 4, this is the higher E naught. And for lower E naught, you're going to do the same thing. Okay, so who's going to lose electrons? Now we're going to focus on losing electrons. Now at the moment, the lowest E naught is minus 0.04 volts. So that's our lowest E naught. And so it's the one that has the highest tendency to actually lose electrons. But again, I have a problem that if I select this equation as being my oxidation equation, then where did Fe come from? There is no Fe. Like if you look at my reactants, there is Fe3 plus, but there is no Fe. So which is why I can't use this equation. So I'm going to cut this equation out, because this equation doesn't apply to my in my specific case, because we don't have Fe. So we're going to remove that. Then out of the remaining, I mean, if you ignore this, which one has the lowest E naught? It's going to be 0.34. So let's focus on that now. That's the lowest E naught now. Which means that it has the tendency to lose electrons. So if it loses electrons, who loses electrons? It's going to be copper. And do I have copper in my reactants? I do have copper in my reactants. So this equation is fine. There's nothing wrong with it. Copper is the one that's going to lose electrons. So I've selected my highest E naught, and I've selected my lowest E naught. This came out to be my lowest E naught. This came out to be the one that gains electrons, and that came out to be the one that loses electrons. And so when you're selecting, write down all possible reactions, and you also have to ignore those reactions where you don't have the reactants. It should be any one of the species out of these 3 that must be gaining or losing electrons. Now the final part number 4 is just write the overall equation. That's it. You figured out what's going to happen, and the last part is you write the overall reaction. Now to write the overall reaction, you're just going to make the number of electrons gained and lost equal first. So in our particular case, I think Fe3 plus must be multiplied by 2 so that the number of electrons, just for balancing, the number of electrons gained and lost are equal. Because over there, there's copper is gaining 2 electrons. And then you add up the reactants. In the bottom one, it's Fe2, Fe3 plus. Those are your reactants. And in the top one, it's copper that's losing electrons. And your products are going to be in the first one. In the bottom one, it's 2 Fe2 plus that's getting formed. And in the top one, it's copper 2 plus that's getting formed. So we've been able to figure out what the reaction is going to be when you react copper with FeCl3 aqueous, which basically means you're getting an ionic equation. So it basically means that Cl minus 1 ions are spectator ions. The reaction that is happening is between copper metal and Fe3 plus. And Cl minus 1 ions are spectator ions. Nothing is happening to them. They're neither gaining nor losing electrons. Just a second. So I'll just go over this once more. Okay, the first step was that I'll just go over the whole thing. See, so the first step was you had copper reacting with FeCl3, so I figured out what my reactants were. And I told you that ionic compounds, they must be treated as separate ions. So there was Fe3 plus, Cl minus 1, and copper. I wrote down all reactions because I didn't know what was going to happen. So I wrote down all the reactions that involved copper or Fe3 plus. Wherever I saw copper or Fe3 plus, I wrote those equations down, and Cl minus 1 as well. The high E naught gains electrons. So the highest E naught came out to be, initially it came out to be this 1.36 volts, but I did not select that. Why? Because if I selected that, then highest E naught gains electrons. It would be Cl2 that would gain electrons, which is why I did not select it, because I didn't have Cl2. Or by default, the highest E naught came out to be 0.77. And I did select that because I did have Fe3 plus gaining electrons. So I did have Fe3 plus. So that made sense. And when it comes to lowest E naught, the lowest E naught came out to be minus 0.04 volts initially, which means that it was the one that was going to lose electrons, but then Fe was supposed to lose electrons. I didn't have Fe. So once, so I got rid of that equation. I didn't need that equation because I didn't have Fe in my reactants. So the last, ignoring that, the lowest E naught came out to be 0.34 volts out of all of them. And 0.34 volts, that means copper is the one that's going to lose electrons. And that equation is fine because I do have copper over here. Zoa, is this clear?
Yes, sir.
So every time, in your case, it's going to be simpler because you don't have to write down the equations. You just have to mark them in the data booklet or in the table that would be given to you, and you just have to figure out the high E naught and the lower E naught. And as anyway, so that's one example, and you've been able to figure out what the reaction is when copper reacts with FeCl3 aqueous. And you can also figure out the E naught cell for this. The E naught cell will give you an idea of how feasible the reaction is. Achha, bisme the E naught cell is a higher minus lower. It's going to be 0.77 minus 0.34. So subtract the two values. So 0.77 volts minus minus 0.34 volts. And I think it's going to be 0.43. I'm not sure, but I guess it's 0.43 volts. So let's do something. Let's do another question similar to this. Now this one is so this one is let me think first. Oxidize. Just a second. Okay. So CrSO4, chromium sulfate, and it's reacting with acidified K2Cr2, O7, and it's acidified. So I want to figure out what's going to happen. What's the reaction that's going to happen? So starting with step number 1, write down all your reactants. And if it's an ionic compound, write down the ions. It's Cr, which is 2 plus, SO4, which is 2 minus, and then I have K2Cr2O7, that's K plus 1, and dichromate 6, which is Cr2O7, 2 minus, and then there is acidified, which is H plus 1 as well. So I got all these things. Then we move to step number 2. So I want to figure out who gains electrons, who loses electrons. So let's move to step number 2. And in step number 2, you write down. So in step number 2, you write down all possible electrode reactions involving any of them. So starting with chromium 2 plus. So we'll pick chromium 2 plus first, and there are actually 2 equations. So there's and let's select both of them. So 2 equations that involve chromium 2 plus. So anywhere I see chromium 2 plus, I just write that down. So here are my 2 reactions. I got actually not the bottom one. The bottom one doesn't even have chromium in it. So let me just correct that. Where's chromium again? So it's basically these 2. Just a second. So let me. So first one, this involves chromium 2 plus. So I'll just first I'll just copy them. I'll sort them out later. And then there's another one which is chromium 2 plus. So I got chromium 2 plus in this one as well. If you can see over here, it involves chromium 2 plus. So I'll write that down as well. Okay, that involves chromium 2 plus. SO4 minus 2, I'll just pick SO4 minus 2. Where's SO4 minus 2? Anywhere I see SO4 minus 2, something happening to SO4 minus 2, I'm going to write that down. And I see 2 equations for SO4 minus 2. There's SO4 minus 2 in this one, and there's SO4 minus 2 in the other one as well. So let's pick both of them. Okay, just a second. So here's my SO4 minus 2 equations. Then there's K plus 1 as well. So I'm going to write down K plus 1 equations as well. Where's K? It's Hij. So K is right in the middle. Just 1 second. So here's our K minus 2.92 volts. I'm going to pick that. And what else do I have? So I need one for Cr2O7, 2 minus. So let's pick where's Cr2O7. Where did it go? Just a second. It's this one. There's Cr2O7 2 minus over here. There's only one of them. So all possible reactions being written down. And there's H plus 1, so we can write down an H plus 1 equation as well. Although that is probably not required, but here's an H plus 1 equation. So that kind of completes this. And I'll just make them smaller. 1 second. So we've written down all possible equations that involved any of our reactants which were mentioned over here. That's the First part. And let's move to the next part quickly. Who's going to gain electrons? Who's going to lose electrons? So the highest potential, and I'll keep the reactants in front of me. Remember, it should be one of the reactants that is involved. One of them should be the one that should be gaining or losing electrons. So let's start with gaining electrons. Who's going to gain electrons? So the highest potential at the moment is, let's focus on the highest potential that gains electrons. So this is the highest. And it's the one that's going to gain electrons, but you can't. So it's the one that's going to go in the forward direction, gain electrons. But here's a problem. If I select that, who's gaining electrons? If I select that, then it's S2O8 2 minus that's gaining electrons. And we don't have that. I mean, it's not even mentioned over here. So that means can't use that equation. So I'm just going to remove this particular reaction. Ignoring that, which one is the highest E naught? I think that comes out to be 1.33, which is this one. So it comes out to be 1.33, which means it's going to gain electrons. It's going to go in the forward direction. And do I have Cr2O7? I do. There is both things are present. I got Cr2O7 2 minus, and I also have H plus 1. So both of these things are present, which means I figured out who's going to gain electrons. So it's going to be.
Sir, what if अगर सिर्फ दोनों में से एक होता फिर?
नहीं, किन दोनों में से? फिर भी ठीक है.
इसी reaction.
नहीं, फिर भी ठीक है. It's supposed to be one of them that should be gaining electrons.
I mean, अगर एक कोई ऐसा reactant है जो हमारे पास है ही नहीं.
तो ठीक है. तो नहीं है तो फिर हाँ फिर नहीं हो सकता ना. Let's say if there was Cr2O7 and there was oxygen next to it, O2, right? So you can't use that equation because although you do have Cr2O7, but you don't have oxygen. You need oxygen, Cr2O7 with. So in that case, you can't pick that equation. Okay. So just remember, whoever you select who gains electrons, the highest potential, the things must be there as your reactant. Okay. If it's not, if any one of them is missing, you can't use that equation, right? So Baki, the next part is you figured out the first part, that's done. The next part is figuring out the rest. Who loses electrons? So this part is done. Now we're going to try and figure out who loses electrons, the lowest potential. The lowest potential in this case is starting with the first one, minus 0.91. That's the lowest, I think. So that's the lowest. So that means it's going to lose electrons, but can't you?
Potassium
Sorry. Potassium is the lowest. Where's potassium? Potassium is the lowest. So potassium has the greatest tendency to actually lose electrons, but you can't use this equation. You don't have potassium anywhere in your reactants. I mean, you have potassium ions, but not potassium. So we'll just cancel this equation out. Then the lowest is this one, the one I selected earlier. That's the lowest, minus 0.91. But you can't use that equation as well because then it's Cr that loses electrons, and we don't have Cr anywhere. We have Cr2 plus. We don't have Cr. So I'm going to cut that equation out as well. Then which one is the lowest? I think it's minus 0.41. That's the lowest. That's the lowest, and that's the one that's going to lose electrons, has the greatest tendency to lose electrons. And do we have Cr2 plus? I think we do have Cr2 plus. So Cr2 plus is over here. So nothing wrong. This equation works perfectly. There's nothing wrong with it. So that's the one that's going to lose electrons. So I've basically been able to figure out my highest E naught and my lowest E naught, both of them. And I just need to put them together to make a reaction. So So the last step is, so is this part clear? This one, Ibrar, clear है?
Yes, sir.
Yes, sir.
So we're running out of time, so you can do the rest of the reaction yourself. All you have to do is add up the two reactants. Just make sure the number of electrons gained and lost are equal. For example, over here, there's 6 electrons being gained. So there should be 6 electrons being lost. So multiply this by 6 and then add the two equations together. So we'll do some more questions on this, and we'll continue tomorrow with this. Okay? So continue करते हैं next time. ठीक है? Okay, everyone.
Thank you, sir.
Take care.
Yeah,
Love. Love is.
Allah Hafiz.